Today, we will fully explore the mysteries of prehistoric times. Some scientists believe the seeds of life may have been asteroids carrying the basic building blocks of life, or comets passed to the Earth through the vast universe. This idea raises the possibility that life on Earth was not entirely terraformed. Perhaps, in some sense, we are all outsiders. Whether life originated from the Earth or a gift from the stars, every living thing on Earth shares a magical bond. Deep within ourselves lies a common ancestor. In ancient times billions of years ago, spawned all life forms on Earth today. Life on Earth originated from the subsequent emergence of strange creatures. It's really breathtaking. Just imagine, Earth 4 billion years ago, a piece of hot lava, tortured by constant collisions of asteroids and comets. The Earth of that era, Lianyu, seems to be full of hostility. However, in this chaos, something seemingly rare and extraordinary is about to happen. The spark of life is about to ignite. Scientists speculate life on Earth originated approximately 3.5 billion to 4.5 billion years ago. At that time, the Earth was in the so-called Mingu Curse stage. The Earth was full of active volcanoes. The air is full of toxic gases. It is unimaginable that any life could survive in such an environment. The early solar system was also chaotic. Space rocks of various sizes gather into a disk, orbiting around the newborn sun. Gravity pulls these rock fragments together. Sometimes they hit each other and break. Sometimes they combine to form larger celestial bodies, such as planets and satellites. This is how our moon was born too. During the Ming Dynasty and Zhou Dynasty, Earth is still a turbulent world of lava, continuously bombarded by space debris. In one of the most important collisions in Earth's history, it was at this time that it happened. A round star the size of Mars, Tuya, Oia, struck the young Earth with unimaginable force. The collision was powerful enough to throw parts of the Earth's surface and crust into space, forming a debris belt surrounding the Earth. Over time, these fragments gradually gathered to form the Moon. Moon rock samples collected by the Apollo missions prove the Moon is made of the same material as the Earth. The huge cracks on these moon rocks are the traces left by huge collisions. However, this catastrophic event not only created the Moon, it has also changed the Earth in several important ways. The collision tilted the Earth's axis of rotation. This creates a climate with 4 distinct poles. At the same time, the Moon's gravitational pull begins to stabilize the Earth's rotation, preventing violent swings in the Earth's orbit. Otherwise, these unstable conditions would significantly reduce Earth's susceptibility to life. The Moon also began to affect the tides, create mastery of the ocean. This played a crucial role in the formation of early life. These young Earth events laid the foundation for the birth of life. Huge asteroid impact may have laced the atmosphere with carbon monoxide. This may have provided fuel for early biological metabolism and played a key role in the origin of life. Asteroid and comet impacts not only bring atmospheric, also brought complex organic molecules. Fan Zhongluen hypothesis believes that life on Earth, or the basic building blocks of life, may have originated from outer space, microbial or chemical preconditions, and carried by small stars, comets, meteorites, or cosmic dust. If this theory is true, then maybe we can all call ourselves aliens from another world. Even though this sounds like science fiction, but we now know the possibility exists. NASA's OSIRIS mission brings evidence. Scientists are trying to take samples from a small star in space called Beru. As they analyze the returning rocks and dust, it was found that it is rich in water and contains carbon, nitrogen, and other exciting compounds. These are the basic ingredients needed for life. Although this is not the earliest life form on Earth, but scientists speculate the last common ancestor lived approximately 4.2 billion years ago, just 1 year after the Earth was formed. This last common ancestor may have been a single-celled organism similar to modern bacteria or archaea, despite its simple structure, but possesses some complex molecular machinery, includes the ability to copy DNA and produce proteins. This genetic code is still used by all living things today. become us from the tiniest bacteria to the giant blue gold, common connections that even include humans, despite the extremely harsh environment of the early Earth. But this last common ancestor can survive again. Scientists speculate he may be living near hydrothermal vents on the seafloor. The superhot water there is rich in minerals, may provide necessary energy and nutrients for life. Deep under the sea, chemical evolution occurs. Just imagine, the primitive ocean is like a pot of original soup of life, mixed with water, gases and minerals, thunder and lightning. Volcanic eruptions and ultraviolet light from the young sun provide the energy for these chemical reactions. It may be that conditions unique to hydrothermal vents in this environment promote chemical reactions, thus giving birth to life. Hydrothermal vents are like underwater volcanoes. They spew hot water containing chemicals such as hydrogen sulfide. Microorganisms can use these chemicals as a source of energy. This process is called chemosynthesis, may be a key step in early life development. Life may also have originated in diving ponds or tidal pools. There, constant cycles of wetting and drying concentrate organic molecules, drives the chemical reactions necessary for the formation of life. Imagine a small pond where water evaporates in the sun, leaves thick organic material behind. When it rains next time, the pond fills again and new reactions occur. After countless cycles, the foundation of life gradually forms. These first life forms were extremely simple. These ancient microbes are called prokaryotes, without cells and other complex structures found in modern cells. They thrived in the harsh environment of early Earth, rely on chemical reactions to obtain energy and grow. Prokaryotes are like tiny survival machines, able to survive in extreme environments. From hot springs to cold underground, these early life forms had simple structures, but their adaptability and evolution. The transformation ability of blue-green algae is extremely powerful. In the long history of the Earth, blue-green algae, also known as blue-green algae, one of the oldest life forms on Earth. Blue-green algae are capable of photosynthesis, use sunlight to convert energy and release oxygen. It is this process that plays an important role in transforming Earth's atmospheric environment, created conditions for more complex life forms to survive. Archaea are single-celled organisms. They are known for their ability to survive in extreme environments, such as hot springs, rock lakes, and submarine hydrothermal vents. Archaea can survive temperatures above the boiling point of water. Some thrive in highly acidic or alkaline environments. The survivability of these microorganisms indicates they are likely to be one of the first life forms to land on Earth. Prokaryotes dominated life on early Earth, but as time goes by, a leap in complexity came with the emergence of eukaryotes. About 1.5 billion years ago, eukaryotic cells began to appear. They are more complex than prokaryotic cells, have a nucleus to store genetic material, and possess specialized organelles to perform various functions. The origin of eukaryotes is linked to a process called endosymbiosis. Endosymbiosis occurs when a larger prokaryotic cell engulfs a smaller prokaryotic cell and formed a symbiotic relationship. Over time, these engulfed cells evolved into organelles such as mitochondria and chlorine bodies. Mitochondria are called the power plants of cells, produce energy through cellular respiration. Chloroplasts are found in plants and algae and are responsible for photosynthesis. One of the evidences supporting the Negongsheng theory is that mitochondria and chloroplasts have their own DNA. The DNA is similar to that of some bacteria. About 1.6 billion years ago, the earliest multicellular organisms began to appear on Earth. So much so that one of the earliest multicellular organisms was a seaweed that lived in the submerged sea. Although this seaweed has a simple structure, but it marks an important progress in the complexity of life. The emergence of multicellularity allowed organisms to grow larger and develop specialized cells for different functions. This increase in complexity paves the way for richer and more diverse life forms in the future. Over time, complex multicellular organisms began to emerge, The Earth has become more vibrant as a result. About 1.5 billion years ago, a class of early microorganisms called algae appeared. These tiny single-celled organisms are among the earliest known eukaryotes. Algae have a tough shell. This may help them survive in harsh environments. Fossil algae have been found in ancient rock formations from around the world. These fossils show the many forms of algae, show that they are a diverse group. About 1.2 billion years ago, red dates, one of the common marine dates today, began to appear. Red dates capture sunlight through a special pigment. This allows them to photosynthesize in deeper waters. This adaptability allows them to survive in places with little light. Fast forward to about 635 million years ago. Earth enters Ediacarake. During this period, a group of early multicellular organisms appeared in the ocean. They lived on the ancient seabed and took various forms. Dickinson's worm is a flat, segmented organism. Living on the seabed 558 million years ago, it adapted to life under the sea. Survived by absorbing nutrients from microbial mats. Dickinson worms can grow up to 1.4 meters long. Is one of the oldest animals. Long before the explosion of level 5 life in Han, it has already multiplied on the Earth. At the beginning of the formation of the new Earth, the flow of the ground drives the movement of huge plates on the surface. Plate collisions created mountains and volcanoes. Volcanoes continuously erupt lava and gas. At this time, the Earth had almost no atmosphere. But as time goes by, the gases ejected by the volcano are gradually captured by the Earth's gravity. Water was brought to Earth through the impacts of numerous comets and asteroids. Except water, the key to life sprouting on Earth. It also depends on the distance between the Earth and the Sun. The Earth is right in the habitable zone. This allows liquid water to exist on the Earth's surface. In the early days of the origin of life on Earth, the Sun's radiation is the main source of energy on Earth. As it still is now, there was almost no oxygen on Earth at that time. Scientists speculate that solar energy provides the starting power for the transformation of organic molecules. Transform simple organic molecules into more complex molecules, ultimately form the basis of life. Life likely began in alkaline vents on the ocean floor. Its life mechanism may be based on ribonucleic acid, rather than DNA as we know it now. Ribonucleic acid is a type of nucleic acid found in the cells of all living things, believed to have played an important role in early life on Earth. It was during this period that the common ancestor of life split into two major life forms, bacteria and bone bacteria. Although the specific details of this process are still not entirely clear, over the next billions of years, tiny microorganisms continued to evolve. About 3.6 billion years ago, some microorganisms began to experiment with methane, and 3 billion years ago, scientists find evidence of early virus. However, some scientists think viruses may be as old as life. It may even originate with life. In early Earth, some kind of evolution with fossil belt differences occurred at that time. Microorganisms called cyanobacteria evolved, the ability to use light and water to generate energy. At the same time, oxygen is released in the process. The activity of these cyanobacteria causes oxidation of iron dissolved in seawater. A rust-red band of iron formed on the seafloor. However, between 2.4 billion years ago and 2.1 billion years ago, the first major catastrophic event in the history of the Earth occurred. This change, known as the Great Oxidation Event, led to mass extinctions on Earth. The large amount of oxygen released by cyanobacteria was fatal to the aerobic microorganisms at that time, caused the first mass extinction of life on Earth. The high concentration of oxygen was unbearable for microorganisms and bacteria at that time, because their antioxidant systems simply cannot cope with such high oxygen levels. In the end, they reaped the consequences, triggered a global extinction. But the worst is yet to come. About 2.3 billion years ago, the Earth has entered a period of ice. This could be a result of the Great Oxidation Event. Since then, the Earth has experienced many ice ages. Every time a glacier melts, but more oxygen is released into the ocean. This led to the arrival of the Neoproterozoic era. During this period, the earliest animal cells appeared on Earth. They are different from plant cells. Start eating plants. Become the first herbivore on Earth. Although the Earth has experienced at least 2 large-scale ice periods, life still persists tenaciously. This period, fungi, worms, and other symmetrical organisms survived and evolved. As time advances to the Paleozoic era, complex life forms begin to appear. Fish, branching animals, diverse organisms such as ovizoans and vertebrates gradually multiplied. Plants began to appear on the surface of the Earth. Air-breathing animals also climbed onto land for the first time. In the ocean, sharks, horseshoe crabs, and starfish begin to flourish. Insects first became adults during the Neogenean period. At the same time, ferns became the most common plants on land. An early seedless fish, placoderm fish, covered in bone armor, begins to swim. At this time, giant shark, blind barbarian, and silver colloid also began to evolve. During the Carboniferous period, the Earth's climate became tropical. Seasonal changes are minimal. Strange creatures began to appear on the Earth. At this time, plants covered the Earth, and huge forests gradually formed. The remains of these plants were eventually transformed into the coal we use today. The expansion of these forests has allowed atmospheric oxygen levels to climb to about 35%, much higher than the 21% we have today. This could explain why insects became so huge at that time. Some insects may evolve to larger sizes to combat the effects of high oxygen levels. During this period, giant insects such as giant veined dragonflies soared into the sky. Their wingspan can reach 68 centimeters. On the ground, a 2-meter-long giant poisonous centipede crawled. Giant cockroaches and 1-meter-long scorpions also linger in this era of strange creatures. Amphibians began to diversify. Reptiles gradually evolved a mentality similar to that of modern lizards. And because of the evolution of bones, they were able to live on land. Some of these amphibians have evolved warm bodies that allow them to breathe air on land. This transformation completely changed the pattern of life. Animals no longer rely on water sources to invade. For swimming or diving enthusiasts, giant predators like Dunkleosteus have long been extinct. This giant day turtle is nearly 9 meters long, weighs nearly 4,000 kilograms. The top predator in the ocean at the time, able to easily capture any prey. Dunkleosteus, a giant armored fish with no teeth. Instead, its bony branch head, the huge self-sharpening blade formed by the lower plywood. These blades can tear apart any creature that stands in their way. Its bite force is as high as 9.5 tons per square centimeter, enough to rival modern giant crocodiles. Dunkleosteus' head can open and close quickly. This action creates powerful suction, sucks prey directly into its huge body. Even more chilling is the Dunkleosteus will even kill each other when food is scarce. Archaeologists have found fossil evidence of them trying to devour their own kind. If such fish are still alive today, humans will have nowhere to escape in the ocean. However, fortunately, Dunkleosteus became extinct in a series of extinction events in the late Neogenean. Along with it, 75% of Earth's species disappeared. During the transition from the Carboniferous to the Permian, about 300 million years ago, all continental plates merged into one supercontinent, Pangaea. The first large stone herbivores and stone carnivores also appeared during this period, although they look like dinosaurs. But they actually have little to do with dinosaurs, more related to modern mammals and reptiles. A reptile called a double male beast is similar to today's Rongyuan, about 1 meter in length. The head is in the shape of a roundabout. And another famous reptile, Urcomon, body length up to 5 meters. There is a huge sail on the back, probably used to regulate body temperature. Reaching the late second-tier stage, mammals and reptiles began to dominate. The largest species among them is the animal horde. These huge animals have different teeth, used for different functions. Some are herbivores, some are carnivores, Size ranges from less than a kilogram to over a ton. One typical example is the Therocephalian. Their name means canine, have canine-like teeth. These animals have certain social behaviors. There is fossil evidence that they may have hunted in groups. In the ocean, on Earth, fish with real skeletal structures evolved. Sharks and jadefish thrive. Sponges and corals are also widely distributed. On land, insect breaths have evolved to become more complex, able to penetrate and suck. However, about 2 years ago, the Permian loneliness period 5.2 billion years ago, the Earth has ushered in another devastating mass extinction event. In 2001, scientists discovered surprising evidence. An asteroid or comet similar to the one that wiped out the dinosaurs impacted the Earth 200 million years ago, leading to the extinction of giant reptiles. Researchers found high proportions of helium and subgas molecules in the probe. These gases can only come from space. Scientists speculate that the diameter of the celestial body that hit the Earth was between 6 and 12 kilometers. Its impact was equivalent to 1 million times that of the largest earthquake of the last century. Furthermore, there is evidence that, at that time, volcanic eruptions of unimaginable scale also occurred in Siberia and China. These volcanoes spew ash and dust that obscure the sky. Over millions of years, more than 3 million cubic kilometers of lava spewed from the ground, covering the entire Earth, forming a rock formation up to 10 meters thick. The combination of this asteroid impact and volcanic activity, a double blow to the Earth. Earth is once again an uninhabitable world. This disaster caused the extinction of 90% of species in the ocean and 70% of species on land. Still, this isn't the end of life on Earth. The Permian mass extinction event marked the beginning of the Mesozoic era. This period includes the Triassic. The Jurassic and Pleurozoican periods lasted 8.6 billion years. During the Triassic period, the Earth is still a desolate world dominated by Pangaea. The world's climate is dry, extremely hot. The ocean is the vast sea area of Pangaea. The evolution of dinosaurs began in the Middle and Late Triassic period. When we talk about dinosaurs, usually think of the giant Tyrannosaurus rex. However, the latest research shows the ancestors of dinosaurs and pterosaurs were actually very small creatures. New discoveries on the island of Madagascar. All are a kind of life in two. Small reptiles from 3.7 billion years ago. Scientists name it insect butcher. This small reptile is only 10 centimeters tall, one of the roots of the dinosaur family tree. Its importance lies in the fact that miniaturization was a survival strategy used by early dinosaurs to adapt to their environment. Research has found that its teeth have traces of insect wear. This shows that it feeds on insects. Avoided competition with carnivorous dinosaurs closer to their ape relatives. Research also shows that the feathers and fur on late dinosaurs and pterosaurs may have originated from these. Microancestor. They used these feathers to withstand the cold and hot climate of Triassic dry. During this period, the dinosaurs officially began their rise. Sandiagi is the world of reptiles, especially archosaurs and therozoans. Although it is unclear why archosaurs gained an evolutionary advantage, but they finally defeated the beasts and terrors, and in the Middle and Late Triassic period, the earliest real dinosaurs evolved. These early dinosaurs were divided into two major categories, the Raritunmu and the Birdtunmu. The typical representative of the dinosaurs from the Shih-Tzu-Entomb is Lithosaurus. Its body length is 91 centimeters, weighing about 11 kilograms. Long legs enable it to run quickly. Its front paws have sharp claws to help it grab prey. The more evolved dinosaur Herrerasaurus had a mandibular joint and a larger skull. The mouth has sharp carnivorous teeth. The body length of Herrerasaurus ranged from 3 to 6 meters. The front paws have 5 fingers, has thick claws. Another early dinosaur, it's called Storon, about 2 meters long. The skull and bones are equal in length. There are 13 to 14 sharp teeth in the upper and lower jaws respectively. The hind legs are long and strong, able to run fast. Although Storosaurus is small in size, hunting is not a problem. Stanosaurus, Herrerasaurus, and Stegosaurus represent the rapid evolution of early carnivorous dinosaurs. During the same period, the earliest herbivorous dinosaurs also began to appear in the fossil record. Pisanoron was a small dinosaur 1 meter long, weight between 2 and 9 kilograms. Its teeth are closely spaced, creates a continuous cutting edge, easy to chew plants. By the late Triassic stage, at least 15 different species of dinosaurs have inhabited the Earth. Entering the Jurassic period, Earth's climate begins to change, transition from hot and dry to more humid subtropical climates. Large area of ferns, conifers, and other plants began to cover the Earth. Undersea desert air is humid, mixed with tropical majesty. As Pangaea further split, Laurasia in the north split into North America and Eurasia. Gondwana in the south began to break apart. New oceans fill the air between these continents. Undersea mountains rise from the bottom, push sea levels higher. These water-filled areas contribute to a humid climate. What was once a desert is gradually covered by vegetation in a hurry. At the same time, ancient oceans became more diverse. Life is getting richer and richer. In the Jurassic Ocean, many new sea creatures revealed. At the top of the marine food chain are large marine reptiles, like a plesiosaur. Plesiosaurs are known for their long necks and powerful limbs that evolved into. Meanwhile, giant ocean crocodiles, sharks, and squid dominate the ocean. There are many kinds of cephalopods in the ocean, such as tangerines and nautiluses. Ancient sponges and mollusks also thrived, expanding with warmer waters. Coral reefs grow rapidly. Plankton population surges. The water in some areas is even dyed red. In the late Jurassic, earliest birds. Decapita bird appears in sky for first time. It probably evolved from early carnivorous dinosaurs. The will of the Zatunmu dinosaur. But decapods had to survive as pterosaurs competed for space in the sky. Pterosaurs were flying reptiles that had soared into the sky as early as the late Triassic period. Has huge wings and light bone structure. At the same time, various insects such as vernalids and beetles are also thriving on the Earth. And many early mammals were quietly moving under the feet of dinosaurs. During this period, dinosaurs gradually occupied a dominant position on land. And some small four-legged herbivorous dinosaurs gradually evolved into huge hand-raising dinosaurs. One of the most famous herbivorous dinosaurs is Wanlong. Its height can reach 16 meters. It is about 26 meters long and weighs up to 25 tons. Another huge dinosaur, Diplodocus, about 27 meters long, weight between 30 and 50 tons. Their large size may have protected them from carnivorous dinosaurs. At the same time, a terrifying carnivorous dinosaur, Allosaurus, also appeared during this period. The body length of Allosaurus is between 7 to 12 meters, weighing nearly 2 tons. The teeth were sharp, unlike other large, straight-eating dinosaurs. Allosaurus teeth will continue to grow. Exfoliated and replaced, the length of each tooth is between 7 to 10 centimeters. Models show that Allosaurus could run at a speed of 34 kilometers per hour. Fossil evidence shows Allosaurus hunted Stegosaurus. Stegosaurus defended itself with spiked tail. It even once penetrated the skeleton of an Allosaurus. Stegosaurus survived for quite some time into the late Jurassic, and was still active in the early Whitsuchian period. However, the emergence of new predators brings new threats. Tyrannosaurus rex of North America is one of the most representative carnivorous dinosaurs of the late Whitsuchian period. Tyrannosaurus rex can reach 12.5 meters in length, weighs about 8 to 10 tons. Although some studies suggest it may have weighed only half as much as originally estimated. Although Tyrannosaurus rex was undoubtedly the top predator of dinosaurs at the time, it wasn't the only giant carnivorous dinosaur. In South America, Giganotosaurus was about the same size as Tyrannosaurus rex, weighing up to 9 tons. The North African Geelong is even larger, weighed up to 10 tons. Even so, the brutality and deterrence of Tyrannosaurus rex cannot be ignored. But experts believe that the teeth of Tyrannosaurus rex were densely arranged. There may be carrion accumulated in the tooth peaks all year round. These carrion may contain large amounts of bacteria. Therefore, even if the prey it bites does not die immediately, you may eventually die from infection. The bite force of Tyrannosaurus rex is also amazing. It is estimated to reach 2.5 to 5 tons per square centimeter. You can eat approximately 225 kilograms of meat at a time. However, Tyrannosaurus rex also faces challenges. Painter record display. They lived in the same area at the same time as some powerful intellectual dinosaurs such as Triceratops. Triceratops, as the name suggests. Its head has 3 horns, 2 above the eyes. Another smaller corner is located above the nose. Weight ranges from 6.5 to 13 tons. The largest Triceratops can reach 9 meters in length. From nose to tail, shoulder height is approximately 3 meters. Triceratops had closely spaced teeth. Its teeth form several rows of gums. These gums have 3 to 5 teeth stacked vertically. The total number can reach 800. This tooth structure helps it chew tough plants and trees. Triceratops is one of the last dinosaurs to appear late in the white crocodile season. Another famous Ankylosaurus also lived at the same time as it. Ankylosaurus was the largest and thickest member of its family. Ankylosaurus was covered with hard bone plates. It has 4 horns on its head and a club-like hammer at the end of its tail. Can be used to defend against predator attacks. At that time, Ankylosaurus cohabited the Earth with Tyrannosaurus rex and other carnivorous dinosaurs. In the middle stage of the white crocodile class, the hadrosaur family began to rise. The duck-billed dinosaur is a unique herbivorous dinosaur. Have a tough recovery that allows them to easily tear apart plants. These dinosaurs lived in groups, able to freely switch and walk between 2 and 4 races. At the same time, Western horned dinosaurs are also getting bigger and bigger. You might think that Wanlong and Diplodocus are already huge beings, but in the late white crocodile season, Argentinosaurus emerges as possibly the largest land animal to ever exist on Earth. This huge object can reach 30 to 40 meters long, weight between 50 and 100 tons. About 100 million years ago, one day ago, a strange dinosaur appeared in the white crocodile season, Cytopersaurus. These dinosaurs had hard skulls. The top is raised and there are horns around it. These horns may have been used in fighting lawyers, may also be used in fights between similar species and to demonstrate strength. Although more than 700 species of dinosaur fossils have been found on Earth, but this is just the tip of the iceberg. There are still many unsolved mysteries waiting for us to uncover. For example, at the end of the white alligator season, some species of dinosaurs even lived in the cold Antarctic regions on Earth. At that time, the Earth's temperature sometimes dropped to -10 degrees Celsius. These dinosaurs needed to undergo extreme karma for up to 3 months. In 2014, the skull and upper and lower jaw fossils of a miniature Tyrannosaurus rex were discovered in Antarctica. Scientists named this dinosaur Ostrosaurus. It is about 6 meters long and has feathers on its body. These feathers may have been used to protect against cold conditions. It is now generally accepted that all large dinosaur species, including Tyrannosaurus rex, had feathers. These feathers help them adapt to their environment and protect themselves, except Tyrannosaurus rex. Dinosaurs such as ceratopsians and hadrosaurs also lived in the Antarctic region. However, whether it is Ostrosaurus or Triceratops, their time is coming to an end. People often talk about how the dinosaurs disappeared overnight, but in fact dinosaurs ruled the Earth for 6.5 billion years. This makes them one of the most successful vertebrates on Earth. Today's birds are descendants of feathered dinosaurs. This means the dinosaurs were never truly extinct. You may be surprised. Modern crocodiles are actually birds' closest relatives. They all originated from archosaurs. This is why these species are still alive today. 65 million years ago, a huge asteroid struck what is today Mexico's Yucatan Peninsula, brought about the most violent mass extinction in the history of the Earth. This disaster not only wiped out the dinosaurs, also changed the Earth's ecosystem. Researchers use high-resolution imaging, microscopic observations, and magnetic measurements. A detailed reconstruction of how this disaster occurred. If you were in North America at that time and look up at the night sky, you might see a particularly bright star. That's not an ordinary star, but that deadly giant asteroid. This giant asteroid is moving at a speed of 7, approaching the Earth at a speed of 20,000 kilometers. A few hours later, the asteroid with a diameter of 11 to 80 kilometers penetrated the Earth's atmosphere, falling towards the Earth's surface at extremely fast speeds. In less than 3 seconds, it passed through the Earth's atmosphere for 100 kilometers and finally hit the Earth. As this giant asteroid passes through the atmosphere, the deafening sound it made swept across the entire North American continent. If an animal were close enough to see the asteroid, they will be evaporated in an instant. Handle some turtles and crocodiles. Almost all four-legged animals over 25 kilograms did not survive. Asteroids hit Earth so fast, even the air has no time to escape. The air is instantly heated to thousands of degrees Celsius under strong compression before the asteroid actually touches the ground. The compressed, hot air has evaporated the foreshore of the Yucatan Peninsula. This asteroid slammed into the Earth's crust. Huge energy is released instantly. The force of this impact was so great, so much so that rocks and soil flow like liquids. The shock wave is like the huge waves caused when a person jumps into a swimming pool. First, he violently attacked all around, then bounced back in the center. It seems like a huge water splash has formed on the ground. At the moment of impact, the material lifted up from the Earth's crust formed a 32-kilometer high ground wall. The huge crater caused by the impact almost penetrated the Earth's ground. And when the Earth's crust rebounds upward, a mountain peak that is higher than Jumu Nangma Peak is formed. A few minutes later, this huge mountain almost completely collapsed, formed a ring peak. At the same time, this 750 million-ton asteroid, impacting the Earth's crust at a speed of 16 kilometers per second, convert its kinetic energy into extreme heat energy. Molecules in the Earth's crust are excited to temperatures higher than those on the Sun's surface. A fireball of over 10,000 degrees Celsius was instantly formed. As the vaporized rocks spread around at supersonic speeds, this hot gas and powerful shock wave, spreading outward at a speed of more than 1,600 kilometers per hour. The shock wave of the impact was like a huge bell ringing, spread around the Earth. Earth's wave spread in all directions at a speed of 4 kilometers per second, triggered earthquakes around the world. If you were on the other side of the world at that time, you will also feel violent vibrations on the ground after about 30 minutes. The tsunami generated by the impact was as high as 180 meters. Huge waves hit Mexico and southern U.S. coastlines first, and poured dozens of kilometers inland. The powerful impact of the huge waves even washed the river against the current, like an irresistible tide. About 6 hours later, huge waves reach European, African, and Mediterranean coasts. The 180-meter high wave wall beats the land mercilessly. Eventually, huge waves swept over every coast in the world and washed away everything. Then it returns to the ocean with the broken material. But this disaster has just begun. When the asteroid hit the Earth, it throws 25 trillion tons of surface material into space. Some of these substances reach escape velocity, maybe even into lunar orbit, but most matter eventually falls back to Earth, formed a blazing glass rain. This hot-eating glass fish descends on the Earth. Dinosaurs around the world were not immune no matter where they were. However, death doesn't just come from these falling shards of glass. As they re-enter the atmosphere, friction with the air generates a large amount of heat energy, causing global temperatures to rise suddenly. This rain of glass raises global temperatures to the equivalent of baking in an oven, set fire to most of Earth's forests. Many birds were not spared due to the raging fires. Only those birds that lived on the ground survived, and the few large land animals on Earth that have survived are almost all those that can hide. Animals living underground or in water, such as small mammals, snakes, lizards, and crocodiles. This rainstorm is not over yet. Impact site with oily river. This allowed large amounts of sulfides to be released into the atmosphere after the impact. About 1,110 tons of sulfur and hundreds of billions of liters of water vapor were thrown into the sky. These gases then condense into huge storm clouds. Acid rain falling across the planet polluted the oceans. And in higher dimensional areas, large-scale snowstorms can dump dozens of meters of snow every hour. However, this global rainstorm will soon end, because as rivers of smoke fall from the atmosphere, the impact threw tens of thousands of tons of oil up into the stratosphere and condenses there into a layer of black smoke, covering the entire Earth like a black curtain covered with paint. This layer of black smoke hangs above the clouds. It blocks the sunlight and cannot land back to the surface. This scene brings new problems. This layer of black smoke remains in the atmosphere, blocks 90% of sunlight for 2 to 3 years. The Earth has fallen into a long winter. Global temperatures plummet, an average drop of nearly 50 degrees Celsius. The only place to escape this cold disaster was tropical Madagascar, India, and Indonesia. These tropical islands have warmer climates, fortunately escaped the extreme cold. And elsewhere on Earth, evaporation almost stops. Reduce water volume by 80%. Most of the Earth has become dry and barren, like a desert. This series of disasters has almost brought life on Earth to an end. However, where did the boulder that caused the extinction of the dinosaurs come from? Will similar threats come again in the future? According to the researchers' supercomputer simulations, this asteroid may have come from the Oort cloud, a vast region of icy comets and asteroids at the edge of the solar system. It may be caused by the gravitational influence of Jupiter, changed the original trajectory, eventually falling to Earth. As it approached the Sun, the comet disintegrated into multiple fragments. One of them is the main culprit that hit the Earth. Such fragments may occur every crosses the Earth's orbit once every 500 million to 730 million years. December 11, 2021, NASA announced a thrilling news. An asteroid longer than 330 meters travels at 6, flying past the Earth at a speed of 5 kilometers, only 3.8 million kilometers away from the Earth. Although the distance seems far away, but if its trajectory deviates slightly, there may be a direct collision with the Earth in the future. Astronomers are closely tracking this potentially dangerous little star. It is expected to approach Earth on February 14, 2060. By then, the distance from the Earth will be shortened to 1.1 million kilometers. Humanity currently has no completely reliable means to defend against such a huge celestial impact. However, NASA has launched a dual asteroid bug-directed test program. This mission aims to demonstrate a method of crashing a spacecraft into a small star to change its trajectory. The target is a small moon-like object in a small star system called Twins. The spacecraft will collide with a small star in September 2022. By then, the little star will be about 11 million kilometers away from the Earth. Although this impact only slightly changed the speed of the small moon-like object by 1,000th, but this may lay the foundation for dealing with larger celestial impacts in the future. Of course, saving the Earth from asteroid impacts may require more technological means. Perhaps future countermeasures will not only rely on spacecraft. It may also be necessary to use more powerful force and weapons to change the orbit of a giant celestial body before an impact occurs. 1 million years after the extinction of the dinosaurs, Earth has undergone earth-shaking changes. This period is called the Ancient and Modern Season. Earth's continents continue to drift and change shape. Earth's climate is warmer than now. Tropical rainforests are spread all over the world, and sea levels are higher than they are now. After the dinosaurs disappeared, the Earth's ecosystem rebuilt. Mammals get unprecedented opportunity. Millions of years after the asteroid hit, fossil record shows explosion of mammalian diversity. On Earth after the extinction of the dinosaurs, mammals have risen rapidly, occupying various ecological niches. Based on fossil evidence, The ancestors of many early mammals were small lineages. They spread rapidly after the extinction of the dinosaurs and gradually evolved into many branches of modern mammals. One of the earliest mammals from the Jurassic period, Morganmon, has appeared. This kind of small-bodied creatures that feed on insects, one of the common ancestors of all living mammals. Morgania lives in the shadow of the dinosaurs. Nocturnal activities take advantage of a larger brain and keen sense of smell and hearing to avoid competing with reptiles. This evolutionary advantage helped them survive the disaster at the end of the white crocodile season. In the Earth's oceans, ancient marine life has not stopped evolving either. One of the first marine animals to recover after the extinction of the dinosaurs was a close relative of the nautilus. Hungry species, they play an important role as predators in marine ecosystems. In the early stages after the extinction of the dinosaurs, most of Earth's birds are small species. A marine mammal was a species similar to today's sparrow. Among reptiles, turtles, lizards, and snakes also gradually spread across the Earth. Fossil record shows early mammals gradually underwent dramatic changes in body shape and adaptability during the course of evolution. Land-dwelling mammals are not only larger. Moreover, they have become more diverse and efficient in terms of hunting, foraging, and escaping from natural enemies. At the same time, marine mammals such as whales began to gradually evolve from land to water. The origins of whales date back some 50 million years. Scientists believe that the ancestors of whales are a group of animals called pachy whales. This creature lives in the submersible sea and gradually adapts to life in the water. Pachy whales are about the size of a goat, although the body is still like a land animal. But the elongated skull on its head already shows similar features to modern whales. Their limbs turned into flag limbs. The nostrils are moved back and are closer to the top of the head, eventually becoming a whale fully adapted to the aquatic environment. The size of whales increases rapidly, gradually evolved into the behemoth we know today. In the Mediterranean area of the valley, many Parkins fossils have also been found. This foreshore was an important habitat for the evolution of early marine mammals, about 23 million years ago, when the Earth entered the center. But ocean ecosystems have changed dramatically. This period, huge predatory fish such as megalodon become dominant in the ocean. Megalodon can grow up to 18 meters long, the largest shark ever discovered. They have strong jaws and huge teeth. The teeth are sharp enough to easily crush whale bones. Except megalodon, there are also huge ancient whales living in the ocean, such as the 15-meter-long Brazilian dragon whale. This whale is one of the earliest known giant whales. Alongside it is the Leviathan whale. This is a powerful predatory whale. Lived about 12 million years ago. Leviathan whale is 13 meters long. Its huge, sharp teeth indicate it is an apex predator that feeds on large sea creatures. Despite the size of the giant predators in the ocean, but that doesn't mean these behemoths are the only ones on Earth. On the other side of the ocean, there once was a more mysterious and huge ancient marine reptile, the Saurosaurus. They are not dinosaurs. It's a type of marine lizard. Songlong lives in the late white crocodile season. Body length up to 17 meters. Limbs evolve into awards. Adapted to high-speed swimming. They have long heads, toothed ceiling, able to easily catch fish, chrysanthemums, and other sea creatures, despite their terrifying appearance. But actually, on the sea, Songlong is more closely related to today's lizards and snakes. In addition, there is an ancient turtle called the ancient turtle in the ocean. It lives in the late white crocodile season. Huge size. Glue can be up to 4 meters long. They bear some resemblance to today's sea turtles, but it is much larger than any known modern sea turtle species. These ancient creatures not only ruled the oceans, it also demonstrates the ability of life to survive and evolve in harsh environments. Not just the ocean, life on Earth's land continues to evolve. Among ancient mammals, forceps rapidly differentiated. Squirrels evolved into today's rodents. A wide variety of species, including beavers. With the evolution of carnivores, cats and dogs appeared. Ursidae and other predators. The origins of felines can be traced back to the Paleocene epoch, about 66 million to 56 million years ago. That's when an animal called an ancient cat appeared. They gradually evolved the flexible claws and strong jaws that are characteristic of today's cats. One of them evolved into the famous saber-toothed tiger. Saber-toothed tiger and two huge, full-toothed civilizations. These tusks are their weapons for hunting prey. It may also be used to compete for territory with similar species. The evolution of canines is equally impressive. Scientists think the earliest canids appeared in the late Neohistoric period about 56 million years ago. These animals are smaller. Similar to today's foxes, they gradually adapted to various environments, eventually evolved into today's wolves, dogs, foxes, and other species. Except felines and canines, there were other, more mysterious predators on the prehistoric continent. For example, moa. The moa is a large, dark-clouded bird. Appeared in the late Gushing period 62 million years ago. The moa was huge. Can reach up to 3 meters in height and weigh up to 450 kilograms. They are one of the top predators on land. They ruled South America for millions of years. Many other strange creatures appeared on the land. The 10,000 tree barrier evolved into a huge ground tree fence. Can weigh as much as an elephant. They live from the central phase to the more central phase. Good at digging. May use its huge claws to ward off predators. The representative of giant snakes is the giant python. It is one of the largest snakes. Their huge size made them one of the top predators in the forest at the time. Human ancestors also slowly appeared in this long evolutionary history. The earliest primates appeared about 60 million years ago, living in the canopy. Rely on flexible hands and feet and a large brain when taking risks. Foraging and surviving in the forest. Over time, primates gradually evolved, eventually gave birth to the ancestors of modern humans. The history of the Earth is like magnificent symphony, in constant evolution and extinction. Compose a chapter of life.